Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called CMBR by Michael Lefkowitz, which I think in his post he said that it's basically the cosmic microwave background radiation. So I guess these lines are meant to essentially be the cosmic background radiation of the universe. Which is actually a very cool concept of creating a puzzle related to that. Anyways, here are the rules. Normal Sudoku rules apply, which means fill the grid with the digits entirely with the digits 1 through 9 without repeats in any row, column, or box. We also have equal split lines, where each gray line can be split into two non-overlapping pieces with the same sum. So as an example, let's use this 4. You could have something into two overlapping pieces, so it's always 2. So you could have something along the lines of, say, 2 and 5 and 1 and 6. And this works because these two digits add up to 7 and these two digits add up to 7. Or you could have something like 1, 2, 5, and 8 because these three digits add up to what this digit adds up to. As long as there's two non-overlapping pieces and they have the same sum, right? So it has to be split, so you have to use all the digits, and they have to sum to each other. They have to sum to the same sum. That's a more accurate way of putting it. Also, we have Kropke dots, where digits separated by a white dot have consecutive values, and digits separated by a black dot are in a 2-to-1 ratio. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And if this were a 2, this would have to be a 1 or a 4 to make sure that these digits are in a 1-to-2 ratio. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So on each of the equal split lines, they must add up to the same sum. So therefore, this is an even amount of digits, or this adds up to an even number. What does that mean, though? Interesting. So one of these is even, one of these is odd, which means the other one has to be odd. Same here. This is even and odd, which means this must be odd. So one of these is even, one of these is odd. You have to have at least one odd digit here. Okay. Right, so these three digits must be odd because this is even because they sum to the same sum. These are even because it sums to the same sum. So it's 2 times something, 2 times something. Same here, 2 times something, 2 times something. This is interesting because we don't... This... Huh. What does that mean then here? These also are even. This is even, and this is even. Oh, that's interesting. Which means one of these must be odd, and the other is even. Right? Because if they're both odd or they're both even, that doesn't work. Right? Because these add up to the same sum along this line. These add up to the same sum along the same line. So one of these is odd and one of these is even, but we're not sure which is which. Well, what happens when one of these is odd is the question, right? Or one of these is even. Oh. So if one of these is odd, obviously it's 1 and 3 with 2 or 4. Sorry, 1 and 3 with 2 or 6. Okay, so how does that work? If this is odd, you also need an odd and even in this. Okay, that works. But if this is even, that means you need, if this is even, again, these add up to an even digit. You either need 2 evens here, or you need 2 odds here. Either way, one of these is odd. Sorry. Either way, if this is an even digit, this requires either 2 evens or 2 odds, which adds up to an even digit. But since we know these are even digits, and the box as a whole must add up to an odd digit, if this is even, that forces this to be odd. So one of these is going to be odd or even. We know that for certain, and the other one has to be even. So this has to be that ratio. So this is specifically then 1, 2, 3, or 6 in this set. And I think that means this is also the same, right? Yeah, because you have the similar restriction here, right? These are all even. This must be even as a whole. So if this is not, say this was even, right? If this is even, that means these two are both even or they're both odd, which makes an even number. But this must then be odd if that's the case. So either way, this also has to have one odd and one even in this case. So all 4 of those conform to that. It's not, there's nothing related to here that forces that not to be the case, right? So this is all 1, 2, 3, and 6. Because that's the only possibility you can have for crop key dots if one of them is odd. Because of that, we have a 1, 2, 3, 6 quadruplet in box 5, which eliminates 1, 2, 3, and 6 in the rest of the box. Therefore, one of them is the sum of the other 2. And that must be 4, 5, and 9. Right? There's no other 2 digits out of 4, 5, 6, 4, 5, 7, 8, and 9 that can add up to one of the digits. So this has to be 4, 5, and 9, which makes these 7 and 8. Since this is 7 or 8, it's next to 6, 7, 8, or 9. But this can't be a 9. So this would be 6, 7, or 8, which makes this 5, 6, 7, 8, or 9. We don't know what that is. So one of these is a 7. So because if it's either, it cannot be 9 here because it's in between 2 unique digits. And it's consecutive with both of them. And 9's only consecutive with 8. So it could go down to 5. But either way, if it's 5, 6, 7, or it's 6, 7, 8, or it's 7, 8, 9, it requires a 7. So none of these could be 7. Therefore, this cannot be 9. This is 4 or 5. It could be 4, 5, 6. But it cannot contain a 7. So this can't be 4, 5, or 6, actually. This has to be 3 or 6 here, right, with 4 or 5. So now we have a 4, 5, 4, 5 pair, which eliminates 4 and 5 from the rest of the row. So this can't be 4 or 5. This has to be 9, which means this can't be 9. This is 4 or 5. The 4, 5, 4, 5 pair Well, I guess it could be, okay, that's not 4, 5 necessarily. This is not necessarily, this is 3, 4, 5. And this could be 2, 3, 4, 5, 6. Okay, so that's there. Which we know then has to be it's either 2, 3, 4, 3, 4, 5, or 4, 5, 6. It can never contain a 7 here. So 4 has to be here, which eliminates 4 from the rest of the row. So this can't be 4. If this is 9, this becomes 6, 7, 8, and this could be 2, 3, 4, 3, 4, 5. If this is 5, hold up. If this is 9, this becomes 6, 7, 8, or it could be 5, 6, 7. But this can never be 4, 5, 6, if that's the case. If this is 5, it can never be 4, 5, and 6. So this can never be 6 here. So this can't be 5, because it can't be in between any of these digits then. This is 3 or 4. Okay. How does that work? So one of these is 9. So if this is 5, this is 2, 3, 4. If this is 9, this still could be 2, 3, 4. And that could be 5, 6, 7. Or this could be 6, 7, 8 with 2, 3, 4. Or 6, 7, 8 with 3, 4, 5. We just don't know. Okay. What else do we know here? This isn't odd. This isn't odd. I think these two digits have to be the same as these two, right? Yeah, because this pair would eliminate all of these pairs here. Okay, so we're going to color these then different colors. We're going to make these the orange. So these match this one. And this one, we're going to make yellow. It matches that. So this digit must be the same as that digit. Interesting. This digit must be the same as that one. Um. Hmm. Since this is 7 and 8, it cannot be 3 digits adding up to one single digit. It has to be 2 digits adding up to each other. And the only possibility for that to be the case if it's 1, 2, right? So this has to be 1 and 2. This is 1 and 2. This is 1 and 2. This is 1 and 2, which forces this to be 3 and 6. Right? It cannot be 2 and 3 here, because then these are not... This eliminates all possibilities for that cell. So this has to be 1 and 2 added together. So this is the same as... This digit is the same as that. 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 So if this is 1, this has to be 8. So this is either 1, 8 or 2, 7. If this is 1, 8, if this is 1, 8, that means this has to, if this is 1, 8, that means this has to be 1, 7 here, which makes this so if this is 1, 8, that means this has to be 7. Which forces this to be either 6 or 8, but it can't be 6 because this would be 8, 7, 6. So this would be 1, 8. 1, 7, 8 adding up to 8. If this is 2, 7, that means this is 6 or 8. If this is 8, okay, so yeah, what are the possibilities? If this is 1, 8, this has to be either 1, 8 or it's 2, 7. If it's 1, 8, that means this is 2, this is 1. That would mean this is 7, this would have to be 6. So this would be 1, 8, this would have to be a 1. Because this is a 1 here. So this would be 7, 6, 8, this would be 2. And this could be any combination of 2, 5, or 9 here. This would be 2. It cannot be 2, 3, 1, but it could be 2, 3, 5. And it could be 2, 4, 6, or 2. It cannot be 2, 4, 2. So this always adds up if that's the case. Okay, so that's fine. This can never be 5. It's either 4, 3, 2 or 5, 4, 3. So this can't be 4 either. One of these two is 4. If this is 2, whoops. If this is 2, this is 7, this is 2, this is 1. So 2, 7, it could be 8 and 6, and this would be 9. This would be 1, so this would have to be a 1. So 2, 7, it could be 8 here, and this would be 9, and this would be 6. Wait, no, 2, 8, and does not add up with 6. So it could not be 2, 8. So if it cannot be 8, it could be 2, 7 down to 6. So 2, 6, which forces this to be 8. So this is 8 no matter what then. If it's 1 and 7, if it's 1 and 8 here, this has to go down to 7 to go down to 6 because it cannot be 6, 7, 8, and 9. Or it cannot be 8, 9, and 9. It has to be 8, 7, and 6. If this is 2 and this is 7, it cannot be 2 and 8 to add up to another digit because that would be 10. So it would have to be 2 and 6 adding up to 8. So either way, this is 8. So this is 8, which makes that 7, which makes that 8, which makes that a 1. Therefore, this is a 2. This has to be 7. This is 6. This has to be 2. This is 1. And we have this pair. This is a 1. We need a 9 here somewhere, and 1 and something. 1 and 8 requires a 9, but this can't be 1 and so this has to be 3 and 9, 3 and 9, and this is 4, 5, 4, 5. Okay. What does that mean? I'm not sure. So one of these is a 3. That's interesting. Oh, 9 can never be in the middle. If 9 is in the middle, it adds up with another digit to add up to something greater than 9. So this can't be 9. So 9 can never be in the middle of one of these lines. So this cannot be 9 here. If it's 3 cells in length. So therefore this must be a 9. Which means this can't be 9. Add up to 1 and 8. So 2 also has to be one of these 2 digits. If this is 3 and 5, that makes this a 2, which would eliminate all possibilities here. So this cannot be 3. This has to be 4, which makes that 6. Therefore, this is 5, 4, 3 to make that a 2. This is 4. This has to be 3, which makes that 6. This 3 means this can't be 3, so that's 6, which makes that a 3. This can't be 3, so this is 9 and 3. This can't be 4 because of that 4, so this is 5 and 4. The remaining digits here are 7 and 8. The remaining digits here are 5 and 9. So we need something to add up to 9. Therefore, it must be 2, 7, 9. This must be 8, 3, and 5, adding up to that. Okay. That means this must be an even number here. That means this is even. This is an even number because it's equal to 2 times something minus an even digit, which means this is even. So we can remove the yellows, I guess. This is even. Since these are even and this is even, this must be odd. This has to be even because it's the even minus the even, which means this must be an odd digit. Okay. This is an odd value because it's an even digit subtracting an odd digit, which makes an odd digit. This is even because we have an even digit subtracting an even digit. This is an even digit subtracting an odd digit, which makes that odd. So we have, and this is odd. Right, so this was even, even. This has to be odd. Wait. Okay, this is not right. Let's go back to what we did before. Okay. This adds up to 45. This is even. This is even. This is even. This is odd to add up to an even value. Therefore, to add up to an odd value, we already have an odd. This is even. This is even. This must be even then. Okay, so we can remove this and this. This is odd in value. This is even in value. This is even in total. So this also must be even here, right? Because we already have an odd total here. These are even as a whole. So this must be even. So this is even. So we can delete this. This has to be 4 or 8. This has to be 2, 6, or 8. What are these digits? This could be 1, 4, 7, 8, 9. This could be 2, 4, 5, 7, 9. What are digits that consecutive with it? It could be 2, 3, 5. It cannot be 6. So 1 could be with 2. 4 could be with 3 or 5. 7 cannot be with 6, but could be with 8. 8 cannot be with 7 or 9, so this can't be 8. 9 could be with 8. And this is an odd digit. So this is 5, 7, or 9 here. Okay, so since this can't be 1, these two digits must add up to what this digit is. So it cannot be 1 and 2. It could be 3, 4, or 4, 5. So either way, this is 4, and this is with 3 or 5, which forces this to be 7 or 9. 9 could be here. This could be 1, 7, or 9. So it could be 1 plus something equals 9. That's possible. These are consecutive. So it could be 1. Okay, so to add up to this digit would be 1. It cannot be 1, 1, 2, so that doesn't work. Even if this were 2, 3, that doesn't work, so this can't be 2. 1, 3, and 4 add up together. So, and one of these does have to be a 4. That's interesting. It cannot be 1, 4, 5. It could be 1, 6, 7, or 1, 8, 9. What about going this way? 4 and 3 works, adding up to 7. 4 and... Okay, so this cannot be 5, because if we had 5 and 6, they would add up to 11. 4 cannot be here. So again, it could be 1, 3 adding up to 4, 1, 6 adding up to 7, 1, 8 adding up to 9. Or it could be 4, 3 adding up to 7 here. It could be 4, 5 adding up to 9. So those are both valid. The remaining digits in column 4 are 1, 7, 8, and 9. Okay. This can't be 3. So it would be 4, 5 adding up to 9. It could not be 7. This cannot be 1 and 3 adding up to 4, but 4 and 5 could add up to 9 here. Okay. This cannot be 6, 2, and 8, because this can never be 8. So this cannot be 2 even digits here. Oh, I guess it could be 6, 2, 4. That's possible. 2 cannot be on... Well, I guess it could be 2 here and 1, 3 here. Well, no, 2 can't be here. 2 cannot be on this line. Because if it's on this line, it would have to have 2 unique equal digits. Well, actually, it could be 2, 2, and 5, and that's 9. That's possible. 2 cannot be here, essentially. 2 could be here along this line. It could be any of these two, or it could be this one. Sorry, not... Yes. This one. Yeah. It cannot be here, because if this is 2, it would have to be 4 here to add up to 6, which is not allowed. If this is 2, this could be 5 here. Oh, this is even, which means, and this is even, which means one of these is odd. One of these is odd and one is even. We're not sure which. Okay. Um, One is one of these three here. Say this was 1. This would have to be 2 because it cannot be 4 because we already have a 4 in the box. So if this is 1, this is 2. What are the remaining digits? 3, 5, 7, 8, 9. The problem, though, is if you have 4, 5, add up to 9, then you would have 3, 7, and 8 together, which don't add up to each other. If you have 4, 3 here with 7, then you have 5, 8, and 9, which also don't add up together. Therefore, this cannot be 1 here. So one of these is 1. It cannot have a 2 with it. Well, it could, technically. It could be 1, 2, and then that's 3. Well, that can't be 3. So 2 can never be here, right? Since 2 can't be here, 2 has to be here, which means this has to be 2 and 5. Which means this can't be 2. This can't be 2. This can't be 5. This has to add up to 5. So this is 2, this is 5, which makes this 3 and 7. This then has to be 1, 8, 9. So it's 1, 8, 9, which this can't be 7. This can't be 1 or 8, so this must be 9, which means this can't be 9 here. This can't be 9, so this must be 4, which makes this 4, 5, and 9 here. So this can't be 4. None of these could be 9. This has to be a 2. Cannot be 1 with it, so this cannot be 1. So this must be 2 adding up to 6, 7, or 8. So it has to be, cannot be 7 because that's 5 then. This would be 6. This would be 8, which makes that a 1, which makes that an 8. Therefore, this is 7, and that must be a 1. Huh. Interesting. This can no longer be 3, 1, and 2. It can't be 3 and 2 here, so 2 cannot be along here. This cannot be 2 evens, so these both have to be odd. Which means, so we have 2 evens here, 1 even has to be here, and then you have 2 odds. Well, okay, that's kind of wide variety. Okay, can't be 6, it can't be 6, 1 here. This could be this. Okay, can it be the sum adding it to 6? No, because you can't have 2, 4, or 1, 5. So 6 plus something must add up to something. Therefore, this must be 6 and 3 adding up to 9, because 1 can't be here. Therefore, the remaining digits here have to be 1, 7, and 4 or 8. 1 and 7 add up to 8. So that they cannot be together. 2 and 1 can't be together, so it must be 2, 7, which means this must be 1 and 8 adding up together, which means this can't be 1, this is 8, which makes that a 1, which makes that 4. This can't be 8. This cannot be 3 and 1 adding together, so 3 adds with something to add to something. It cannot be 1 or 2. It could be 4, but that would add up to 7. It could be 5. Oh, wait, this is 7, 7. That doesn't work. Oh, wait. Right. So because this can't be 7. Right. We know this does have to be 3 and 9 because 6 cannot be added up to with 2, 2, 4, or 1, 5. But these 3 digits could add up to that digit, which is exactly what it has to be because it can't be 2, 7 here. Can't be 2, 8. This has to be 2, 1, and 4 adding up to 7, which makes this an 8. Okay, there we go. This 3 cannot be added up to with 1 and 2, so it has to add up with something to something else. 3 cannot add up with 1 or 2 because they can't be there. 3 and 4 add up to 7, so that's not allowed. 3 could add up with 5 to add up to 8, and cannot be add up to 6 with 9 because 9's there. So this must be 5 and 8. This can't be 8. One of these is odd, one of these is even. Okay. 8 cannot be here or here, so 8 has to be here, which is the even. So this cannot be odd, therefore this is the odd. Cannot be 1, 5, or 7, so this is 3 or 9, but it cannot be 9, so this must be a 3. These digits add up together, so it's 2, 5, 6, and 9. So 2 and 9 must be together, and 5 and 6 must be together. Well, 9 can't be here, 9 can't be here, so this must be 9. 2 can't be here, so this is 2, which makes this 5 and 6. This can't be 6 because of that 6, so this is 5, which makes that a 6. These digits must have a 4 and a 9. These two digits must add up to each other, because you cannot have 1, 2, and 4, or 1, 6, and 4 adding up to 9. So this has to be 1 and 9, and this must be 4 and 6, which makes this a 2. Okay, and the rest is just Sudoku, right? These remaining digits in column 9 are 6 and 9. This can't be 9, so this must be 6, which makes that a 9. The remaining digits in row 1 are 1, 5, and 6. This can't be 1 or 6 here, so this must be 5. This could be 1 or 6 either way. The remaining digits in row 2 are 2, 4, and 7. This can't be 2 or 7 because of the 2 or 7 in the column, so this is 4, which makes that 6, which makes that 4. This 6 means this can't be 6, so this is 1, which makes that 6. This is a 2, 7 pair here. The remaining digits in column 1 have to be 3 and 5. This can't be 5, so this must be 3, which makes that 5. That's 3 because we celebrate, because we know we're getting close to solving this. The remaining digits in row 2 are 1, 2, and 7. This, therefore, is either 1 or 7. This could be 1, 2, or 7. The remaining digits in column 3 are 2, 7, and 8, but this can't be 8, so this must be an 8 here. This can't be 2 or 8, so this must be 7, which makes this 2, which makes that 7, which makes that 1, therefore that's a 2. The remaining digits in row 8 are 3 and 4. This can't be 3, so that's 4, which makes that a 3. That 4 means this can't be 4, so that's a 1, which makes that a 4. And now we know this has to be a 1, and this must be a 7. And that's how you solve it. Pretty cool, actually. Very interesting equal split line rule set. Never run into it before, but makes things very interesting. It could be very hairy. For example, I forgot about this being potentially a 3-digit number adding up to 1. Fortunately, I was very much dissuaded very quickly because of this 7. But yeah, very interesting rule set. With the equal split line not being separated by any visible indicator. Very cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.